So to start this problem, you remember you have to work inside out. Okay, so on the inside, they're saying sine of 7 pi over 4. What is that value? What's the ratio? So when you're given an angle, you're trying then to find the ratio. So 7 pi over 4 is the same as 315 degrees. Degrees are easier for me. So I know that we're going to be in quadrant 4. I look and think, okay, 270 plus what gets me to 315? 45 degrees. So 45 degrees plus 270 gets me to 315 degrees. I know if I'm halfway between quadrant, the X and Y axis, I know that at halfway in quadrant 1, 45 degrees, I have root 2 over 2, root 2 over 2. So then we're going to reflect that down 45 degrees from the x-axis from 0 degrees. And we have root 2 over 2 for cos, comma, negative root 2 over 2 for sine. So then we know that the sine at 315 degrees is negative root 2 over 2, which we insert over here. So then for inverse sine of negative root 2 over 2, you're doing the opposite. You're asking yourself at what angle you now want the angle. Is the ratio negative root 2 over 2? But remember, for inverse sine and inverse tan, our options are between negative 90 degrees and positive 90 degrees. So we know that the angle where sine is negative root 2 over 2 in between those two quadrants is negative 45 degrees. That's the angle, or negative pi over 4. So that's our answer. Now for the next one, you work inside out. We're saying inverse cos. We're trying to find theta. So we know that our triangle is either in first or second quadrant because we're between 0 and 180 degrees. Now, 3/5 is not a half, root 3 over 2, root 2 over 2 for cos. So we're going to set up a triangle and just refer to that angle as theta. So we know cosine is adjacent over hypotenuse. So we do adjacent is 3, hypotenuse is 5. We do Pythagorean theorem and we figure out that the last side is 4. Then we work on the outside. We're asking ourselves, what is the sine of theta? Okay, because we don't know that exact angle value. We're not going to put in our calculator to get decimal. So the sine opposite of our hypotenuse in reference to this theta angle, which we don't know, the ratio is going to be 4/5 for opposite of our hypotenuse. So that's our answer. Again, for this next problem, we work inside out. So if we can't figure out the exact angle, like 30, 45, 60, negative 30, negative 45, negative 60, negative 90, then we're just creating a triangle. Since inverse secant is going to be restricted to negative 90 and positive 90, since we have a positive ratio, we draw a triangle in first quadrant. And we don't know the exact angle, so we're just going to make a triangle, and we'll refer to that angle as theta when we work on the outside. So we know that secant is hypotenuse over adjacent, so we fill that out. And then to find the last side, we do Pythagorean theorem. So we know that a squared plus b squared equals c squared. The hypotenuse is 3. So we know that we don't know an actual number, but we can call our adjacent x. So we want to isolate y. So, because y is the unknown side. And then we get that unknown side, or the opposite, is square root of 9 minus x squared. So then we work on the outside. We work with cosecant. If we know that cosecant of an angle is hypotenuse over opposite, this is our ratio. Then we rationalize the denominator by multiplying by square root of negative minus square root of, 9 minus x squared. Then we end up with 9 minus x squared in the denominator, and then on top we still have 3 times square root of 9 minus x squared. Now you can't, change the 3 and the 9 because in the denominator there's 2 terms and both terms aren't divisible by 3. So this is our final answer. For the next one, when we see cos, then cos inverse 1/2, when you're doing the inverses, you're given a ratio, so you want the angle. Now we know that we can get the exact value if it's 1/2, root 3 over 2, root 2 over 2, or if it's talking about tan, right, root 3 over 3, root 3, or 1. So if we are asked to find any of these angles, if those are the ratios, we know those, and we don't have to create a triangle and then just say we're going to refer to theta. So inverse cos, we know that since it's positive, we're talking about the first quadrant, and we know that at 60 degrees, right, at 60 degrees, we have 1/2 comma root 3 over 2. Since cos is on the left, at 60 degrees, our cos is 1/2. So then we plug in for inverse cos of 1/2, 60 degrees, because we were trying to find the angle. Now, working on the outside, we're asked, what's the cos of 60 degrees? So you're going in reverse. Given the degree, we want to find the ratio, and at 60 degrees, the cos, left side of the ordered pair, is 1/2. So when it says inverse sine of negative 0.83, because we have that decimal, we're going to use our calculator. And it doesn't matter what mode you're set to for the inverses, because it's just a ratio, but it depends if you want your answer to be in degrees or radians. So I like to set the mode to degrees. So if you hit the inverse sine button, parentheses negative 0.83, and your mode is in degrees, you'll get out negative 56.09 degrees, which makes sense because inverse sine needs to be between negative 90 and positive 90. So we would be down here at negative 56.09 degrees. Okay, this inverse cotan one kind of messes with people, right? Because we don't have the reciprocal cotan, secant, cosecant in our calculator, but we always work with the reciprocal. So reciprocal of cotan is tan. That button is in our calculator. However, you have to flip what's in the parentheses. So we do 1 over whatever that value is, or if it's a fraction, we just flip it. So we hit the inverse tan button, parentheses 1 divided by 1.83, close parentheses, and our answer, if the mode's in degrees, is 28.65 degrees. Over here, inverse cos 1.23. The value inside is a ratio, right? So, like if you have 1 over 2, that's 0.5. The reason we have some other funky ones like 0.82, it's fine. You can have a ratio. Ratios are decimals, right? You could have it in fraction form, or you can have it written as a decimal. But anyways, we never have a value on the unit circle where an angle where the cos is larger than 1. So there is no value undefined. Lastly, if we work inside out for this last one, sine at pi over 2, we're at 90 degrees, right? At 90 degrees, we have 0, 1, so the sine's on the right, so we have a value of 1, which we insert over here. Then inverse tan of 1, right? Our inverses, we have to look between negative 90 and positive 90. Since it's positive, we know that the ratio of sine, which is root 2 over 2, over cos, root 2 over 2, has a tan value of 1, and that's at 45 degrees, or pi over 4.